Hi, in this video, I will be solving Center 2 of Reeborg's World. So here we have to find the center of the world, and the height and width of the world will change each time, but they will be an odd number from 1 to 11. It's a level 6 difficulty problem, and they have given a few of the inbuilt functions as hint. So from the question, I understood that there would be around four edge cases to solve, where height and width will be one each. So the robot has to stand still and put the object. In case two, the height is same, but the width is an odd number. It can be anything. In case three, it is m into n grid. We don't know the exact number of the height and width. Here, the width will be 1 and height, we are not sure. So, we'll do how to find this. The simple logic is we'll find the height, we'll find the width. We divide both by 2, and the answer which we get, we round it up and make the Reeborg move those many steps and put the object. For example, if we can see case 3, x is equal to 5, y is equal to 3. Now I'm dividing this by 2, so this becomes 4.5, y becomes 1.5. When I round up 4.5, it is 5. When I round up 1.5, it is 2. So x5 and y2 gives me the center. The same logic applies for all these cases. Now, let's come back to solving the problem. To start with, we have to keep a note of height and width. GIG here. Let's start with 0, and width is also 0. Since we are not aware of the grid size, I'm choosing a while loop. When it is true, it has to check if there is a wall in front. If there is a wall in front, the grid on the screen is an M cross N matrix, so there is no wall in front. But if the case is something like this, or case 1 or case 4, it has to first check if there is a wall in front. If wall in front, turn left. When it turns left, give me a minute. So when it turns left, it faces upwards. I mean the north. So in this case, there is a wall, but in this case, it is like the front is clear, so it is able to move. So if wall in front, turn left. So either ways, if the wall is in front, turn left, and height is equal to 1. So if there is a wall in front, the height is 1. If the path is clear, then the width is 1 and the height we are not sure what is the height. So if there is a wall in front, height is for sure it is just 1. Else, if the front is clear, like here, it turns towards the left and the front is clear. The width will be 1 and we have to call the found center function. Again, if there is a wall in front, wall in front, wall in front, wall in front. Um, so in this case, it comes till here. Uh, it turns left, wall in front, and it again has to turn back. So I'm writing this function. Width will be equal to 1. When height and width are same, we have to call the found center function. So in found center function, what we are doing is hmm, so how do we find the center? It comes till here. Hmm. If front is clear, so it turns left and it will be facing something like this. If front is clear, it has to move forward. Yes, here also front is clear, it has to move forward. Here the front is not clear, here there is a wall. When it comes here and it turns left, there is a wall here. So in this case, when front is clear and there is a wall on right. So here there is a wall on right. Here there is a wall on right. And wall on right. I have found the width. So for whatever width is there, I have to move so many steps, come out of the loop, put, and done. So this handles this scenario. For the others, it has to turn left. So it comes till here, 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 here. So it has to turn left, turn left, turn left. It comes till here. Again, turn left. So turn left. Over divided by 2. Since I'm repeating the same thing, we can also use this logic in a separate function. Move turn left, and we are finding the height round of for I in range of height. Move, come out, put and done. Now here I have to Okay, so if while if wall in front, okay, how do we solve um this and this case? So if so if front is clear, it has to move. So here in this case, the front is clear, it has to move till it finds a wall. So here the front is not clear, so it has to turn left and move go towards the north. So let me okay. L not facing the north and yeah, facing move and take the record of the width. So once if it is not facing the north, it has to move forward. And here, if the wall is in front, it will turn left. So when the wall is in front, it will turn left, and it will be facing the facing towards the north. When it faces towards the north, it has to move up, and when it again faces a wall, it has to turn left, and again it faces a wall, so turn left and come down. So that's the logic. So I'm writing an another LF condition. LF is facing north. If it is facing north and the front is obviously clear, so it will move and keep track of the height. HGIGHT. And so when it is facing towards the north, it will move. And if it encounters a wall in front, it has to turn left. And we found the center. Called the found center function. Let me check if this works. Yes. Oh. Hmm. Okay. So it goes till here while true, in front no. So turn left and found center. Okay, now it, oh, I'm sorry. Wall in front, turn left. So when it, if front is clear and wall on the right, okay. So it has to again turn left and come down, right? Let me see what is wrong. Okay. One in front, on left, height is equal to 1. Front center is not facing width. If it is facing height, it should not turn left here. Okay. Yes, it is working now. Okay. So let me check if center one is also working. Yes. Uh, this code has covered all the edge cases. I hope you understood the explanation. If more explanation is needed, please comment down. I'll get back to you. Thank you for watching and stay tuned for more Reborg solutions.